So on page 3 with number 1. Now, this one wouldn't be too bad to try to factor. Sometimes though with the X method, it's like, ooh, do I really want to try like 6 to 8 different combinations to try to figure out if the solutions are able to be found? Folks, let's just go ahead and try to factor this one. If I'm looking for a product of -4 and a sum of -3, could I find this by factoring? Yep. X minus 4 and x plus 1. So then if I have something times something equals 0, either this one is equal to 0 or this one is equal to 0. X is equal to 4 and x is equal to -1. How would we describe these solutions? Two real rational roots. The nice thing is, if you're a little uneasy about factoring, is we can check ourselves on this using our calculator. Go ahead and go to your y equals and type in that equation. X squared minus 3x minus 4. And when we hit graph, does it look like we have x-intercepts at -1 and +4? Sure does, and we can verify this by hitting the trace button. So I'm on my graph, I hit trace, I type -1, and what should I get for a y value? This is truly a solution. We should get a y value of 0. This verifies that -1 is a root, and if I type 4, it shows me that that indeed is my other solution. Folks, your calculators are here as a tool. You still have to show me how the factoring works or how the quadratic formula works, but your calculator is a tool for checking. We're going to go ahead and look at this next one. Now, if I were to try to factor this, do we have a GCF? No, and in fact, we've got a problem because our A value is negative. So before we even try to factor this, we're going to move everybody over to the right side by adding the 3x squared, subtracting 12x, and adding 8. So this is the standard form equation I'm going to use. Can I take out a GCF? Nope. Do I really want to try to use the X method on this one? I can, but let's just see what the graph looks like. So go to your y equals and type in 3x squared, arrow over to escape the exponent, minus 12x plus 8. I look at the graph. Does it look like we are going to have exact roots? Looks a little sketchy on the right one there. If I hit trace and try 1, we see that it is not 1, 0. So I'm going to have in between x-intercepts. Now, it could mean that I have 2 fractional intercepts, or it could mean that I have 2 irrational roots. So it's up to you from here. Do you want to try factoring and then have to use the quadratic formula, or do you want to just use the quadratic formula from the get-go? I say from the get-go because, again, you're going to be mad if you try to factor it and show all that X method work. It's like, it can't even be factored. How annoying. Now it's irrational. So this is a problem where I would probably start with the quadratic formula. So using this version of the equation, I'm going to actually cross this off so I'm not even tempted. Quadratic formula is -b, -12, plus or minus the square root of b squared, parentheses, minus 4ac, all over 2 times 3. I'm going to turn you loose on this. See if you can find the discriminant, simplify the square root, and simplify the fraction. And don't forget to describe your solutions. We end up getting something friendly, like fractions, or are we going to get irrational numbers? We know from our graph that we shouldn't get an imaginary solution, so if you calculate the discriminant and you get something negative, it means you done goofed somewhere. So that's why keeping that discriminant in mind is a good idea, and also comparing it to the graph. Folks, if you're stuck on the graph, wondering how to get back to your calculator home screen, you hit second mode to quit. So second mode takes you out of the grapher and back into the actual calculate part. What are you guys getting for the discriminant? Should be getting 48. So square root of 48. Is 48 a perfect square? Yes. It is not. So that means we're going to be left with stuff under the radical. So we can already describe these as two irrational roots. Now you still got to simplify that square root. So you still have to simplify the square root. But we know that we're going to have two irrational roots. So first we simplify the radical. 2 plus or minus. What's the biggest perfect square we can take out of 48? Biggest perfect square. 16 is the biggest. A lot of times 4 jumps out to students first, but if you look at 12, then you can take an additional perfect square of 4 out. So 16 is going to be the biggest perfect square. And your other non-perfect square factor would be 3. This is all over 6. We have to completely simplify the radicals first before we do anything else. So 12 plus or minus, the square root of 16 is 4. So 4 rad 3. All over 6. Now, using division distribution, 12 divided by 6 is 2. I can take a 2 out of the 4 and the 6, which will leave me with 2 rad 3 over 3. And I can leave my final answer as such. But the two roots would be 2 plus 2 rad 3 over 3 and 2 minus 2 rad 3 over 3. And we can describe these as two real irrational roots. And we can check this on our calculator. The graph I already had in there from the first step. I hit trace and I type 2 plus 2 rad 3, close off the parentheses around the 3 to complete the radical, divided by 3. Boom, right on the money, we get a y value of 0. And if I try the other one, 2 minus 2 square root of 3, close off the parentheses, divided by 3. There's our other intercept exactly. So nasty, nasty decimal, but that is what gives us that output of 0. So you can use your calculator to check yourself. Folks, I'm going to turn you loose on number 3. You can put it in standard form. You can try factoring it right away if you want, or you can look at the graph first, but plan your attack on whether you want to use the quadratic formula or factoring. So if I were you, I'd be looking at that 96 going, it's kind of a large number. If I go to my y equals and I type in that standard form equation, x squared minus 4x minus 96, does it look like we have exact x-intercepts? There's one, hopefully there's another one, far to the right somewhere outside of our 10 by 10 window. So if I hit trace, it looks like this is at 1, 2, 3, 4, 5, 6, 7, 8. So if I try -8, woohoo! There's one of my x-intercepts. So what's nice about this is it kind of guides my factoring a little bit, that one of the factors should be 8. So if I factor this, 96 divided by 8 gives me 12. Which one do I want to be negative to get the sum number to be -4? 12. The 12. So x minus 12 and x plus 8. Product of -96, sum of -4. So either x minus 12 equals 0 or x plus 8 equals 0. X is 12. X is -8. 2 real rat roots. We're going to start abbreviating rational because I want to. So, do we see why it's good to have the graph, factoring, and the quadratic formula at our fingertips to decide the best method of solving? And if you're like, I'm going to use the quadratic formula on everything, I'm not going to stop you, but there will be a portion of the test where you have to factor. So don't just be like, I'm always going to use the quadratic formula, because factoring is faster and it is a skill that we will need beyond the quadratic formula for other things down the road with rational functions. So it is important that you know both of those. To me, quadratic formula and factoring are like the two most important things that we do in Algebra 2. So take it to heart, spend time learning that song. Folks, let's go ahead and take a look at this next one. 10x squared plus 11x minus 6. I'm going to look at the graph first because factoring that, there's no GCF. I don't really want to do the x method and be SOL, but let's find out what happens here. So it's between our tick marks, but doesn't that look like it's almost exactly between -1 and -2? For fun, I'm just going to try -1.5. Ooh. So -1.5, whoops, you guys can't see that, is an exact root. So this was kind of like directly in between the tick marks, which made me think maybe it's not irrational and maybe it's a nicer, friendlier fraction. So since I'm getting a fractional root, should I try to factor? Yeah. Factoring is easier than the quadratic formula, and since I'm getting a rational number, we should go ahead and try to factor. So 2x and 5x, and let's try 3 and 2. This gives me 4x. This gives me 15x, and ooh, feeling lucky because if I make that 4 negative, we can make that 2 negative. And don't forget, folks, when you're doing the x method, you need to check to make sure you're getting that right product number sign correct. So 3 times -2 is -6. And then we go straight across with our factors. So 2x plus 3 and 5x minus 2. Now, if you decided to use the quadratic formula for that one, you would just need to be careful that when you simplify it to your two exact answers. So similar to what we did on this one up here, you want to make sure that you're not leaving it in this form, because 5 plus or minus 6, we can simplify to be 11 and negative 1. So that's another kind of sketchy thing about using the quadratic formula is you need to make sure that you simplify those answers fully. So those are my factors equal to 0. So either this factor is equal to 0 or this factor is equal to 0. And when I solve those two little mini equations, subtract the 3, 2x equals negative 3, divide by 2, and x equals negative 3 halves. Over here, add the 2, divide by 5, and x is 2 fifths. How many solutions did I find? 2. And how would you describe them? 2 real rational roots. On your own, I want you to try number 5 and number 10. I'm going to give you some time to work through those. And in the meantime, I'm going to show you what the quadratic formula would have looked like for number 4, because I think it's important to show that simplifying part. So go ahead and try the next two problems on your own using your calculator to determine the types of roots you'll have, and if it would be better to use the quadratic formula or factoring. And in the meantime, I'm going to show what this one would have looked like using the quadratic formula. Ew, okay, let's pull together for a moment, folks. So, as promised, I decided to try that one that we just did using the quadratic formula. Look at this discriminant we got. 361. Guess what its perfect square factors are? 19. This is not a perfect square I would expect you to know. And if you sat there trying to figure out factors for it, you'd be like, I'm not really finding anything. That is a disgusting, disgusting number. Now, it is a perfect square, so we do get 19. Division distribution gives me this. Now, from here, I divide this into the positive solution and the negative solution. If I have negative 11 plus 19, what does that give me? 8 over the common denominator of 20. which simplifies to be 4/5. And then this one, negative 11 minus 19, we'd get negative 30 over 20, which simplifies to be negative 3/2. Did we get the same answers? Ooh, girl, I made a mistake somewhere too. Now we got the same answer, so divide a 4 out of both of those, we get 2/5. So we got the same answers, but this, pretty terrible. Dividing it up into the positive and negative solution, pretty awful here as well. So folks, even though we don't love the X method and you would have a few different combinations to try here, it still is in your interest for those decimal roots to try factoring first. So how are we doing on number 5? Factorable or not? Yeah, product of negative 24, sum of negative 5. What are my two numbers? Negative 8 and positive 3. You're righty. And so set each of those factors equal to 0. And x is equal to 8 and negative 3. Skipping a few steps there. So 2 real rational roots. 2 real rat roots. That's fun to say. 2 real rat roots. And if you had typed that in on your calculator, you would have seen that they were exact, or you could have just gone straight into the factoring first. Now on number 6, it's not in standard form, so let's go ahead and put it in standard form. 3x squared minus 10x plus 5 equals 0. And when I type this in on my calculator, 3x squared minus 10x plus 5. Ooh, the intercepts are not exact, and it doesn't look like it's a friendly fraction like 1/2 or something. So this is one where I probably wouldn't mess around with the X method. I would probably go straight to the quadratic formula. But how many options would we have if we wanted to try to factor it? 1x and 3x, 5 and 1, that gives me 1x, that gives me 15x. That's not going to work. We try 1 and 5, 5x and 3x, that's not going to work either. So if you want to try factoring first, just because it can be kind of awful doing the quadratic formula when the roots are rational, it's not a bad idea to start there. So now that didn't work, so quadratic formula time. Quadratic formula is negative b, negative 10, plus or minus square root b squared minus 4, a value of 3, c value of 5, all over 2 times 3. So positive 10 plus or minus, let's see, 100 minus 4 times 3 times 5, 40. Not the worst number to get under the radical, but I do need to simplify it by taking out, what's the perfect square factor of 40? 4. So 4 and 10 over 6. So 10 plus or minus 2 rad 10 all over 6. Division distribution. And I get divide by 2, 5 thirds plus or minus. Take a 2 out of both of those. Square root of 10 over 3. Yuck! 2 irrational roots. And if I were you, I'd go, those are kind of nasty. I'd sure like to check myself. On the graph, you hit your trace button and type 5 divided by 3 plus square root of 10. Close off the parentheses to say that the 10 is the only thing you're taking the square root of, divided by 3. And we see that we get exactly 0. Use your calculator to check yourselves. This is a hard test. The quadratic formula is difficult to use. There are lots of different places you can go wrong. Check yourself as much as possible. Folks, we're going to go ahead and stop with that for right now. In the homework packet, you can now start working on page 3, all of these solving quadratic equations. You either got to show that you factored it, or you have to show that you used the quadratic formula. If you just write the answers, you're not going to get credit for that work, and you can take a big L on the test on that section with an ID or a 0. So you have to show how you solved it, either by factoring or the quadratic formula. So folks, once we are done with the homework quiz, that's what you can be working on, is that purple packet. That is not going to be due until tomorrow night. So tomorrow we're going to be doing more quadratic formula simplifying, and then you will have some more work time. So what we're going to do right now is the 4.3 homework quiz over complex numbers. So go ahead and clear everything off your desk.